So this is Form A of the circuit quiz that you guys took in class on Friday of last week that we're going to go over right now. The multiple choice that you see here will be similar to the multiple choice section that you're going to take in class on Wednesday. It starts with this question with a parallel circuit. And you've got a few questions that go along with this circuit. It tells you to use the schematic below to answer the questions that follow, and those questions specifically are going to apply to 1 and 2. Number 1, you guys struggled with. Number 2, you did pretty good on. So let's go ahead and take a look at number 1 first. It says, which of the following would be the reading for the ammeter A6? So first things first, A6 is this one right here. And so it wants to know what the ammeter reading is, which is the current. I did encourage you to use some colored pencils or highlighters or something to outline the loops on your circuit, because some of your charges follow this loop here. You'll notice that that does not go through A6. So A6 is not measuring your total current. It is only measuring a portion of it. Specifically, if you draw in the loops, you can see which portion it's measuring. This light green one that I just added would be measured by A6, but so would this one that I'm adding in purple. And so if you can figure out the amount of current that you have going through these two resistors, and you can add those currents together, that's how you're going to go about finding this. And you're welcome to construct one of those tables if you find it helpful to organize your calculations, the same ones that we've been using in class. That could be used, or if you want, you could just go and solve the pieces of it. But we need to figure out what we know about each of these resistors. And I do know that in a parallel circuit, which that's what this is, in a parallel circuit, I know that my voltage drops are all going to be equal to each other, and they're all going to be equal to the battery. And that's because of one of those laws, Kirchhoff's laws that we learned, that says the voltage drops along a loop add up to the battery. Well, the pink loop only has one voltage drop. The green loop only has one voltage drop. The purple loop only has one voltage drop. There's nothing to add. Each of these has a 20 volt drop. So 20 volts here, 20 volts here, 20 volts here. Okay, and so if I want to go and solve for my current, I can go back to Ohm's law. V equals I times R. And I know my voltage drops here, 20, here, 20. So it's going to be a similar calculation for each one. I'm going to have my 20 volt drop equal to the current that I'm trying to find, because I want to figure out what the current is through each of these. And then the resistor that's labeled on it. So I'm going to start with the 5 ohm resistor. And that will give me the current through that branch, which is the light green one in my sketch here. The current through that one, 20 divided by 5 is 4 amps. You're welcome to type it in a calculator, but you should not need to for that one. And then we have to do the same thing. So this one is 4 amps. And then do the same thing over here and figure out what the current is through this branch. Again, the voltage drop is still 20. That is a property of a parallel circuit. It is equal to I, which we're looking for, times this resistor, which has a resistance of 8. That one maybe you can't do as easily in your head. I don't know. You can type it in the calculator. 20 divided by 8. Oops, this has something typed in. 20 divided by 8. Okay, and again, you may have not needed to type that. I don't know, but I'm getting 2.5. So the current here is 2.5 amps. Again, I can make sure that that makes sense with what I'm expecting. I'm expecting current in a parallel circuit to favor the path of least resistance. This is less than that. That does make sense. You can just make sure, just real quick, that can help you identify if you made an error. And now all you do is add them together, because that's what it's doing. It's measuring both of those added together. 4 plus 2.5 is 6.5 amps. So the answer to number 1 should be C. Okay, now could you have done the entire table and calculated all the pieces? Absolutely. Did you need to? No, you don't ever need to calculate everything. Okay, but if you're having a hard time getting started and you're having a hard time figuring out how to go about doing that, then by all means redraw that same table that we used in class. Okay, so that is the answer to number 1. Number 2 goes with the same circuit, and it says, what is the power dissipated across R1? I didn't actually solve for the current in R1, which I will need to do because my power calculation, and again, you can find this on your formula chart, but your power is V times I. If you put it into the table, you can see it because we organize them in that way. Okay, and so, and again, on your formula chart, by the way, just to make sure, it's right here. P equals V times I. Okay, they're in the electricity section. Here's your resistance calculations. There's Ohm's law, and there's the power calculation. All right, so back to this. That in order for me to solve for the power, I do need to know both the voltage, which I do. It's a parallel circuit. The voltage drop is 20 everywhere because it's equal to the battery everywhere. And I just need to get the current. So I do need to do this same process for this resistor. So we're going to do that first before we can plug it in. And so I know that 20 will equal I times 10. Okay, that's the resistance here. And so the current will end up being 20 divided by 10, which of course is 2. Okay, so that's how you figure out the current there. And then your power is 20 times 2, which is of course 40. The answer to number 2 should be D. I'm not sure how you guys ended up getting this one right, but not this one. I don't know. But 84% of you got number 2 right, and number 1 only 50% of you got right. So I'm not sure exactly where the disconnect was, but y'all did okay on 2. Okay. Are there questions about numbers 1 or 2? All right, then let's move on to question 3, which has our favorite, a combination circuit. Okay, this is a combination circuit because it has a parallel section along with something in series with it. You also saw some combination circuits on the little half sheet quiz. One of them was similar to this type. The other one looked like this. Okay, this is still a combination circuit because it has series and parallel. But this one, we have parallel and then something in series. And it says the circuit below contains 3 resistors, R1 through R3. The current is greatest through which of these resistors? Again, guys, if you have a parallel circuit or a combination circuit, in both cases, I'm going to make the same recommendation. Trace your loops. Even if you don't think you need to, just do it. Okay, that way you don't accidentally make a mistake with your math or with understanding the path that the current takes. One of those paths looks like this one that I just colored in pink. The other path looks like this that I'm coloring right now in green. And these are the paths that your charges take as they make their way through the circuit and back to the battery again. Okay, you do need to know that in order to help you answer the question. Okay, again, brightness, actually this doesn't ask about brightness, this just asks about current, so that's even easier. Okay, current, if I'm trying to figure it out, I don't need to do any math here. Could you? Sure. But I know that there's some total amount of current, whatever it is, and that total amount of current happens anywhere that these two lines are together. And then I know my current splits. So if my current is, let's say, 1 amp, well then this is going to be less than 1 and this is going to be less than 1 because together they add up to 1. So maybe one of them is 0.8 and the other one is 0.2 or whatever. I'm just making up numbers. The point is that these are both less than the total, which means this one absolutely has to have the most current going through it. I don't need any math for that. The answer to number 3 should just be C. Okay, a lot of you guys missed this and you chose, it looks like the most common wrong answer was A, which is R1, which I'm assuming you picked because it had the least resistance. In a parallel circuit, you're absolutely right. The current does prefer the path of least resistance. And if this was a parallel circuit like the one just above, then yeah, you would pick the one with the smallest resistor. But this isn't a parallel circuit. All of the charges have to go through here. And so it doesn't matter what the resistance is, it will have the most current because they have to travel through that point on their way back to the battery. That's why if you trace the paths, you can see it a little bit better. So those of you who did not choose to pull out some highlighters, maybe pull them out when you take your test. I would recommend it. All right, are there any questions about number 3? Yes, sir.
I thought you couldn't draw on the test.
You can't, but you can redraw the shape on your paper and just trace it. I had people do that and just, you don't even have to draw the resistors, just draw boxes and then trace it.
changed because it went through the resistance and then it
The total amount of current, when you're, if you were to calculate a number value, the fact that this is here and these are set up like this absolutely affects the total current in the circuit whenever you do the calculation. But you still, whatever that number ends up being, you still have only part of it here and only part of it here. And then the total has to go through here. So yeah, when you're doing the math, yes, you're going to be ending up with less total resistance in this section, but you still have the total current. There's only one path, even counting that, whenever you're making your way back to the battery. So the total goes through here. All you have to do to figure that out is do the color-coded part. If that still doesn't make sense, we'll try to readdress it at the end, but let me get through it. Are there any other questions? Okay, let's keep moving on. By the way, a common question to be asked with one of these has to do with brightness, just to mention it, because that's what I actually thought this said at first. If you were determining brightness, obviously this does have the most current. It would also have the greatest voltage drop. I don't even have to do the math. I know it does because that's already higher than these two. Okay, and so this would be the brightest bulb as well if the question was worded that way. Okay, so if you do have a question about which one of these is the brightest bulb, if they're all light bulbs, it's almost always this one over here that's in series with your battery because it does have the most current every single time. And it's usually going to have the most resistance unless you have crazy big numbers over here. Okay, that would be the only potential way that you wouldn't have the most resistance, but you usually do. All right, number 4. Number 4, you guys did pretty good on. 75% of you got it right. It says identical resistors are connected across the same 12-volt battery. Which circuit has the greatest equivalent resistance? And again, when you're thinking about equivalent resistance, you do need to recognize that 2 of these are series circuits and 2 of them are parallel circuits. And your equation for equivalent resistance, if I can get it to focus, is different in series than it is in parallel. I'm trying to focus it. All right, there's your equations. Okay, in series, it's just the sum of the parts, but in parallel, it's the one with the fractions, and so the calculation is different. If you're looking for the greatest equivalent resistance, that's going to be your series circuit that has the most resistors, since it says they're all identical. This one is going to have the greatest equivalent resistance because, again, as you add more of these in parallel, your resistance goes down, not up. Okay, so even though this one has 4 resistors, this one actually has the least equivalent resistance because it also has 4 pathways. We had an analogy where we likened it to traffic and having 4 different roads to get somewhere instead of just one. Okay, and so this one has the most equivalent resistance, this one has the least equivalent resistance. Another question I could ask you with a circuit that looks like this, and not could, will, it'll be on your test, is instead of asking which has greatest equivalent resistance, I could give you these exact same 4 pictures and say which one has the greatest current. And then it'd be the exact opposite. Okay, whichever one has the least equivalent resistance would have the most current. This one would have the most current. This one has the most resistance. All right, number 5. Number 5, not the best. 57% of you guys got number 5 right, so there were quite a few people that missed it. It says the schematic shows 3 identical light bulbs connected in parallel, which would result in an increase in the brightness of bulb 1. Okay, first things first, just glancing at these, I do see an option for all of these, so I do need to make sure to read through all of the choices, just in case, because some of you sometimes read the first one, you're like, that's it, you circle it and you move on, and if you see in all of these, just make sure you check all of them. Okay, the first statement says removing bulb 2 from the circuit. Okay, we didn't really talk about what happens when you remove a bulb from a circuit and how that affects brightness. You could go and calculate it with some fake numbers if you want, but for now I'm going to leave that one and see if I find something else that I know is true, and then maybe I can do it by process of elimination. Or if I find out the next 2 statements are both true, then I know it's D. Okay, the next one says replacing the filament in bulb 1 with a thicker wire. If you have a thicker wire, this is one of the factors that affect resistance. A thicker wire means that you have less resistance. Okay, we talked about those different factors. Thicker wire or larger cross-sectional area, which is another way of wording that, is going to decrease the resistance in that light bulb. And so bulb 1, if bulb 1 has less resistance, that means that more of the current will flow through it. Okay, and if more of the current flows through it, remember power is voltage times current. If you have more current flowing through it, that goes up, and the voltage drops stay the same. This is a parallel circuit. They're the same everywhere. So if I increase my current, that will absolutely increase my power, and the reason I'm looking at power is because power is brightness. So increasing power increases brightness. B is correct. I'm not sure about A, but I know B is correct. So let's keep reading. If C is correct as well, then we know that it's D. If C is wrong, then it has to be B. Okay, so let's look at answer choice C. If you have half the voltage in your battery. Guys, if you have half the voltage here, then you're going to have half the voltage drops in each of them. That would actually bring the power down, not up. That would make all of my bulbs dimmer. So this one can't be true. So it doesn't even matter if I know what happens in A. By the way, A is not true. Okay, but even if you didn't know that, by process of elimination, because you know B is true and because we know C is not, it can't be D. And if there's only one answer, then we already found it. It's answer choice B for number 5. By the way, if you did remove bulb 2 from the circuit, your brightness stays exactly the same. Okay, I know that seems maybe slightly counterintuitive, but you can test it out in the FET. If you don't believe me, build a parallel circuit and test it, because you'll get the exact same amount of brightness doing that. All right, and you can calculate it to prove it, but that one takes math. So I wasn't going to do that. We're going to do it without math as much as possible. Okay, let's move on. Number 6. Number 6, about 70% of you got right, so pretty good. Not the best, but decent. It says, if the bulbs are identical, in which circuit would the voltage drop across each light bulb be 4 volts? Again, one of our laws says the voltage drops along a loop add up to the battery's voltage. These are series circuits, so we have different voltage drops on the same loop. Well, this one's not series. This one I know my voltage drops are equal to the battery, 12 volts. So I already know this one is 12, 12, and 12, which means it's not 4, which means I can cross that one off. Okay, but in my series circuits, I need to have them add up to the battery. If this one is a 12 volt battery, and these are all the same bulb, because that's what it says, then this one would be 4, 4, and 4. That appears to be our answer, but let's double check. This one is a 2 volt battery. That would make this 1 and 1. This one is a 4 volt battery. So these would have to add up to 4 volts, making them each 1 1/3. Okay, but the one that's going to give us 4 volts across each is answer choice A. Questions about number 6? All right, then let's move on and look at number 7. Number 7 says, which voltmeter reading would give the greatest reading of electric potential difference, which is another name for voltage? Okay, again, voltage is measuring the energy change in the individual charges. You only get a voltage reading if you're measuring across a place where there's a change. So like this, for example, would be 0. Okay, if you measure just across a piece of wire where there's nothing happening in that section of wire, you're going to have 0 change in energy, and so your voltage reading will be 0. So I know that it's not going to be C. That's not going to be the greatest. Okay, you're going to get a greater reading when you measure across a greater amount of total resistance, or if you get the total reading for the battery, of course, that would be greatest as well. This one is only measuring the 5 ohm resistor. This one's measuring the 1 ohm resistor. I already know that I'm going to have a greater voltage drop when I have more resistance. So I know that it can't be B. But if I look at D, D measures both of them, which would be the total. It would be the same if I measured the battery. Okay, and so this one is going to give you the greatest reading of electric potential difference because it's measuring across the greatest amount of resistance. Okay, the total resistance in between is the greatest. So the answer to 7 should be D. Questions about number 7? About 2/3 of you got this one right, so it was, like I said, pretty good, but could be better. All right, number 8 is also about 2/3, 65%, so close. And it says circuit A and B are identical, except circuit A has two 1.5 volt batteries, whereas circuit B only has one 1.5 volt battery. So you can see that in the picture. The only difference is the battery voltage. Which of these statements is true regarding these circuits? Okay, so basically, if you increase the voltage, what happens? That's what it's asking. Circuit A has twice the resistance of circuit B. Okay, changing the voltage of the batteries does not change resistance. Okay, the resistance is determined by the bulbs. So if the bulbs are identical, which it says they are, it says the circuits are identical, okay, then you're not going to have any change at all in your resistance because it's not dependent upon the voltage. It's dependent upon the filament in the light bulb, which we didn't change. The second one says circuit A creates twice the charges that then flow through the circuit. And this one is tricky because this word right here should be sending off red flags. We've talked about this before, but if you don't remember, it's one of those common misconceptions I discussed. The batteries do not create the charges. Okay, so there are no charges being created at all. So circuit A isn't creating twice the charges. It does have twice the push to move the existing charges, but you do not have 2 times the amount of charge because the batteries don't make the charges. The charges are already present in the wire. Okay, so we're not going to pick statement 2. Which, by the way, we can already eliminate those and this one because those have 1 and 2 in them. So it's either 3 or 4 or both. 3 says circuit A has twice the voltage of circuit B. That's the easiest, obvious statement because if this one has 2 1.5 volt batteries, that's 3 volts, and this is 1.5 volts. So yeah, we have twice the voltage in A as compared to B. This one is correct. Okay, but again, we need to check statement 4. The flow of charge in circuit A is twice the rate of circuit B. This right here, flow of charge, is the definition for current. Okay, and so basically it's saying, hey, circuit A has twice the current of circuit B, which is true because if you look at Ohm's law, V equals I times R, and if you have 2 times the amount of voltage and your resistance staying the same, then your current has to be twice as much mathematically. They are directly proportional to one another. So doubling the voltage, leaving everything else the same, will, of course, also double your current. So both 3 and 4 are correct, which is answer choice D for number 8. Questions about number 8? All right, let's move on then and look at number 9. Pages are sticking together. Number 9 says, if all bulbs and power sources shown are identical, which circuit contains only 2 lit bulbs? We should know this from having done it in class, and you did. You guys did really good because you guys basically built stuff like this in your circuit house. This question, 97% of you got right. Okay. Basically, you're only going to have lit bulbs if they lie along a path that has complete connection from the battery and back again. So in this one, this is your pathway. Now there is another loop here, but you're not going to have charges flowing through it because that's open. Okay, and so this one would have 2 bulbs lit, which I believe is the answer. It is. This one would have 0 bulbs lit because all the switches are open. This one would have only 1 bulb lit because these are lying on a branch with an open switch. They're not going to light up. So this one would be 1 bulb. And then this one would have all 3 bulbs lit. So the one with only 2 bulbs lit is answer choice A. And as I said, almost every single person got that right. Questions about number 9? Okay, number 10. Number 10 says the greater the power rating of a light bulb, and we've got some options. Again, double check first, but there is no all of these. There is a none of these, so you do want to read them carefully. But the first option says the brighter the bulb, and we've talked about this over and over again. Brightness is power, so more power, more brightness. Okay, that was just something to memorize. So number 10 is A. We can read the other ones. Shorter the bulb will last before burning out. No. It doesn't even really matter once you figure out that that one's right, but less work being done by the charges in the circuit, no. All right. Number 11 compares 2 circuits, circuit X and circuit Y. which are only different because of the number of resistors. They all have 12 ohm resistors, but this one only has 1, this one has 2. And it says, which correctly compares the current in the 2 circuits below. So it's basically asking, hey, when I increase the resistance, what effect does that have on current? Our first option says circuit X has greater current than circuit Y. And circuit X does have less resistance than circuit Y, and less resistance does mean more current, because that is that inversely proportional relationship that we've talked about over and over again. That is your answer. Okay, the other one says that it's less. That would not be true. Obviously, less resistance is going to be more current. And then this one says they're equal. Also not true. 11 should be A, and 90% of you got it right. So again, that was one you guys did really well on. Okay, number 12. Number 12 says, what is the resistance of a typical 1800 watt hair dryer plugged into a 120 volt outlet in your home? This is just an Ohm's law calculation. Okay, Ohm's law, of course, V equals I times R. Well, I say it's Ohm's law. It's actually not. It's 2 steps. Okay, because this is power. So we're actually going to have to use the power equation and then Ohm's law. But it is just a pretty straightforward calculation, 2 steps. But we have power and we have voltage. So we actually have to use this equation first. P equals V times I. So use your power equation so that you can solve for I. And then once you have that value, you can plug it in here and you can solve for resistance. Okay, so it's 2 steps, but they're 2 pretty easy steps. So if you want to start with your power, you have your 1800 watts. And you're going to set it equal to your voltage 120 times I, which means the first step in this problem would be to divide 1800 by 120. So let's do that. 1800 divided by 120. And that's going to give you a current of 15. Okay, now that you have the current, you can plug it in up here. Okay, so again, going to the second equation, my voltage is still 120. I'm going to set it equal to I, which is 15, times R, which is what I'm looking for. Okay, so it's 2 steps, but they're 2 pretty easy steps. 120 divided by 15 is how you're going to go about solving for R, so that you can isolate that variable. And when you divide those out, you're going to get 8. And so the answer here is 8 ohms. If you stopped early and got 15, some of you may have picked C. Make sure you do that second step. Questions about number 12? All right, 13. We're almost done. Number 13 says, what is the current through the 10 ohm resistor in the circuit schematic pictured below? Guys, this is a series circuit. So if I want to find the current through the 10 ohm resistor, it's the same current that's going through the 5 ohm resistor and the 2 ohm resistor. It's the same current that's leaving the battery. There's only one loop. Again, you can even color code your loop here if you want, but there's only one of them. So your current is the same everywhere. That was one of the properties of a series circuit. I can measure it here, I can measure it here, I can measure it here. It doesn't matter. Pick a spot. They're all the same. Okay, which means that the current moving through your series circuit is the total current. So when you go about solving it, make sure if you're trying to solve for total current that you're using total resistance and not just using this number. That's how you end up making a mistake here. So my total resistance, the equivalent resistance in this circuit, is 5 plus 2 plus 10, which of course is 17 ohms. That's the value you're going to use when you calculate your current. So if you only used this, you did get the wrong answer. I know my total voltage, I know my total resistance. This is just Ohm's law, V equals I times R. 24 equals I is what I'm looking for, and R is 17. Okay, if you put 10 there, that's how you end up with the wrong answer, which I'm sure some of you probably did. Yep, there was quite a few of you actually. About 2/3 of you got it right, and about 1/3 of you put the same wrong answer, 2.4. Okay, that's wrong. So 24 divided by 17 gives you this, 1.41176, or as it says here, it is rounded, 1.4 amps. Questions about number 13? Again, please be careful with those series circuits. Make sure you're using the total current. All right, last question. You will see this picture on your test. I'm just telling you right now. It says, a lab group took measurements of current and voltage for a parallel circuit during a physics lab. Their setup for these measurements is pictured below. What tool is represented by number 2 and what is it measuring? Again, you guys have used these tools, these voltmeters and these ammeters. And so whenever you look at this and you focus on number 2, you should recognize, hey, number 2 is connected in series. And if I want to connect it in series, that makes it an ammeter. Okay, that means we're measuring current here. That's how you connected yours when you did your lab. So 2 is an ammeter, it's not a voltmeter. By the way, the voltmeters are these two right here that are connected in parallel. These two are voltmeters. Okay, so not those. The only ones that are ammeters are 1 and 2. It's asking about number 2. An ammeter is going to be measuring current by definition. Voltmeters measure electric potential difference, which is voltage. That one's just memorization. Number 14 is C, and 75% of you got it right. Questions about that? All right, guys, as I've mentioned to you already, you are going to be taking the free response section first. Okay, and that's because those are different by period. So you should expect to do that tomorrow. We'll go over that as well and make sure that you understand what you missed and how you missed it, and I'll put a video up in case that is of help also, and you can check back for this. If you're looking for extra practice, or if you look at your quiz grade and you did terrible on it, do the unit summary. It's posted in there. It is a daily grade redo. It's also a really good review for your test. All right, if you guys have any questions, please let me know.